So lesson 2 in the trigonometry unit, say we're looking at multi-triangle trig, that is problems that involve more than one triangle at a time. Some of the keys here are you're often going to have problems that you can't solve directly. You may have to have steps or multiple parts to get to the answer that you want. Okay? Sometimes you got to break a problem into 2 sections or 3 sections. Sometimes you have to find a shared side or a shared angle. Again, the challenge here is going to be trying to draw the pictures. First one, I've given you a picture, but when you get to the ones that don't have the picture, maybe try drawing those before you go right to the example on the video. Okay, so let's get started on the first one here. We're looking to solve for x. I'm looking at x, I'm seeing a right triangle. Unfortunately, the only thing I know is one angle in there. I know 19 degrees, and that's all I already have, so I can't directly solve for x. However, if I were able to figure out the value y here across the bottom, I'd have a side and an angle, which would allow me to solve for a second side. Nice thing about this is looking at the bottom triangle, the y is the opposite, the 15 is the hypotenuse, and I can solve for y, that shared side, by using the bottom triangle, which will allow me to solve the top triangle. In the bottom triangle, we're going to look for sine, because we have O and H, so the sine of 61 equals my opposite, y over 15. It's in the fraction, which means I'm cross multiplying. 1 times y is y, 15 times the sine of 61. Okay, everything's in the right spot, so we can put that directly into our calculator, and we've got 13.12. Okay, and now that I know that, I can go back to the initial question, the one where I wanted to find x. Okay, restart this, think about the fact that y, okay, I know that's 13.12. I'm now solving just the top triangle. I don't have the y anymore, right? I have that length there now. I'm using my 19 as my angle to decide the ratio, so now I have the opposite being x, the adjacent being 13.12. That's a TOA question, a 10. The 10 of 19 equals x, the opposite, over the adjacent, the number we just found. Okay, that shared side, that's kind of the key here. Again, x is in the top, means in cross multiplying. So 13.12 times the 10 of 19, all in the right spots. Put in our calculator, we end up with 38.1. So even though I wasn't able to solve for x directly, by using the idea of a shared side, I can work through one triangle to solve the second triangle. Okay, so let's look at example 2. Read it over, see if you can draw the picture. If you can, that's generally the hard part. The math is a little bit more straightforward. So what do we got going on here? From the roof of a small building, so we're standing on the small building right here, and the angle of elevation to the roof of a nearby building is 15. So remember, elevation works from the horizontal. So if I look straight off the roof, I'd be looking halfway up that building, but I'm not. I've been asked to look at the roof of the building. So the difference between the horizontal and where I'm actually looking is my angle of elevation, in which they tell us is 15 degrees. The angle of depression to the base of the same nearby building is 37. Again, think about the horizontal, but I'm looking down at the building now, so my difference is from the horizontal down. So that would be 37 degrees. Okay, and the buildings are 65 meters apart, so I know this distance is 65. Okay, and I want to know how tall are the buildings. So I want to know this building, and I want to know this building. So I've got an x, and if you will, I've got a y over here, right? Now I'm going to move the buildings apart just for a second here, so we're going to look at this picture and see the fact that we actually have some triangles here. Okay. I hope you notice that we actually have 2 right triangles, right? We have the top one right there, okay, which is right angled, and I have the bottom one right there, which is also right angled. And if I actually really stop and think, I move this y for a second here, I hope you agree that this is x, right? The bottom triangle on the left and the right have to be the same, and this part up here would be the top triangle, and together x plus y would be the tall building. Right? So if I can solve for x and I can solve for y, I can actually solve for both things, both buildings. One of the little tricks here, just remember that 65 meters, the distance between the buildings could be at the bottom here, or couldn't I move that to the top too, right? Doesn't that the same distance? Yeah, so if I put that back there for just a second, I know this is 65 meters. If I look at these two separate triangles, look at the 15 triangle. Well, this would be my opposite. This would be my adjacent. That tells me 10. If I look at the 37 one, this is my opposite. And this is my adjacent. That's also 10. It's the same question with just two different angles. So if I set this up, I'll do the x one first, the 37 one. The 10 of 37 equals my opposite, x, over the adjacent, is 65 meters. And well, x on top, it means I can cross multiply. 1 times x is x. 65 times the 10 of 37 puts everything in the right spots, in the right orders. Don't have to rearrange anything. I get 48.98. Okay, we just figured out how big x is. In other words, we just figured out how big the small building is. If I do the exact same thing, but I use the other triangle, again it's 10 because we had O and A, but this time we have the 15-degree angle. Now it's going to be y over 65. It basically looks the same, right? The only thing we've changed is the angle. So the same process. Y equals 65 times 10, 15. Punch all that in our calculator and we'll end up with 17.42. Okay, why would we find out y? Well, together, remember we said x plus y would make the large building. So if I take those two things together over here, x plus y, which is 48.98, plus 17.42, I'll get a total of 66.4. And again, it's a word problem, so let's use some words to answer this. We're going to say this small building, in our diagram, that was letter X, which we said is 48.98 meters, and the tall one, which was X plus Y, is 66.4 meters. And that takes us to the end of the second example. Okay, I'm going to do all three examples in the same video this time, just to save the time here. Okay, so we flip the page, try drawing it, pause it, see if you can figure it out. If not sure, watch the video. Again, it's multi-triangle. That's kind of the hint here. Okay, we got a tree growing on top of a cliff. Okay, kind of like this little clip art thing is here. I'm going to change the diagram just a little bit so it makes it a little bit easier to think about this. Okay, so let's make the cliff straight up and down, if you will, and the tree straight up and down. From a point 18 meters away from the bottom of the cliff, so the bottom of my cliff, let's say this is right here. There's the bottom of the cliff, right, like that. There's my tree going up like this. Okay, from a point 18 meters away, and that's right angled. The angle of elevation at the top of the tree is 18. So up to the top of the tree, 18. Remember, horizontal upwards, right? If we were looking at the bottom of the cliff, our angle would be 0, but now we're looking at the top of the cliff, so we raised our eyesight. The angle of elevation to the top of the cliff is 16. Okay, so from the same spot, I'm going to the top of the cliff next time. I'm going to draw a separate line, a different color. There's the top of the cliff, right? And that angle is 16. Again, from the horizontal right here, up to this dotted line, here's my angle of elevation. We want to know how tall the cliff is and how tall the tree is. Okay, well, to do part A, the cliff, if you stop and think about this, the blue one, I'll redraw it just for a second here. Okay, we have an angle of 16. We know it's 18 meters away, and this right here would be the top of the cliff, right? That's my x. Well, I can solve that. I've got a opposite and an adjacent. That's a tan question. So I can say that tan of 16 equals x over 18. Cross multiply. 18, 10, 16. Put all my calculators all in the right spots, and I'll get 5.16. Here we go, the cliff is 5.16 meters tall. That was easy enough. Hey, now I want to find the tree. Now the tree, I hope you would agree, change colors here, it'd be from here up to here, right? That part of a triangle. That is not really a right triangle. I can't really solve that. However, I know that in this initial thing that we started here, I had a big triangle to start, did I not? I had a triangle that went all the way to the top. It had an angle of 18. If I can solve the entire triangle, not just the tree part, but if I can solve the entire thing, that total height, that includes the tree and the cliff, I can figure out the tree part by subtracting the cliff part. Yeah, so if you think about that, I'm just going to redraw it for a second here. And sorry about the bells ringing there. Okay, so do it in part B. I know I have an angle of 18. I have a total height there. I know this is 18 meters still. That hasn't changed. And that y includes the tree and the cliff. Well, again, this kind of looks like an O, an opposite, and an adjacent, a tan question, all over again, right? The same kind of tan question we just did a second ago. And so I can say the tan of 18 equals the opposite, y, over the adjacent. Okay, cross multiply and solve. So y will be 18, 10, 18. Punch out all my calculator, I get 5.85. Now remember in our diagram here, we had the cliff, that would be from here up to here, and then we had the tree on top of that, right? So if I want to figure out the tree itself, I need to take the total, and I have to subtract the cliff. My total was 5.85, so we just solved. And initially in part A, we said that the cliff back up here was 5.16. So the difference between the total and the cliff, a difference of 0.69, has to be the tree. So therefore, the tree is 0.69 meters tall. Okay, and that takes us to the end of multi-triangle trig questions. Okay, give the homework a try again. Maybe try a couple of the quiz questions today. That'd be a good idea to see how you're doing with this before we move on to non-right angle triangles.